Let's have a look at a few queries from P1, June 19, 1, 2. Question number 4. Angle x is such that sin x is equals to a plus b, cos x is equals to a minus b, where a and b are constants. Show that a square plus b square has a constant value for all values of x. How do we get a square plus b square? How do we get a square plus b square? See, we cannot link sine and cos together, right? But once we have sine square and cos square, can we link them together? If I ask you what is sine square x looks like, so that is a plus b square. And if I ask you what is cos square x, you will say that is a minus b squared, right? So I will say that sine square x is basically a square plus 2ab plus b square. And cos square x is a square minus 2ab plus b square. Is this right? Now I can add both of them and I'll say that sine square x plus cos square x is equals to a square plus 2ab plus b square plus a square minus 2ab plus b square. Make sense? You've added both the equations, the left side added with the left side and the right side added with the right side. I know sine square x plus cos square x is what? 1. And on the left side, I am left with 2a square plus 2b square. 2ab plus and minus 2ab cancelled out. I take 2 common and I am left with a square plus b square. So a square plus b square is 1 upon 2. Proven, shown that a square plus b square is a constant value no matter what value of x I plug in. This will always yield me 12. Sorry, 1 upon 2. Is this clear? Part 2. Now the question says that in the case where tan x is equal to 2x plus a in terms of the, how do I get tan x? If I take equation 1 and I divide it by equation 2. So I'll say I'll get sine x upon cos x is equals to a plus b upon a minus b. Is this right? I'll get this as tan x, which is a plus b over a minus b. And this is 2, so a plus b upon a minus b. Convert this into the form that a is in terms of b2. Okay. Whenever you come across such a problem, take all the a terms on one side and the non-a terms on the other side. That's the easy and the simplest way. Now, this one. Form the inverse of both the functions. How do we do that? Y is equals to 3x minus 2. Make x the subject of the formula. I'll just write the entire thing as the inverse. Y is equals to 2x plus 3 upon x minus 1. Y multiplied by x minus 1. 2x plus 3. So xy minus y is equals to 2x plus 3. X needs to be made the subject of the formula. Take all the x terms on one side and the non-x terms on the other side, y minus 2. Is this right? Huh? यही बनेगा? So it is y plus 3 upon y minus 2. So G inverse of x is x plus 3. What can I say? When will this be not defined? When, for what particular input the function will not be defined? When x is 2. So I'll say that x is not equal to 2. Is this clear? The next part says f g x is equals to 7 upon 3. Okay, so f g x is equals to 7 upon 3. What do I need to do? I need to take the entire function of g and I need to input it in f. F g x is equals to 7 upon 3. So 3 and 2x plus 3 minus 1. Minus 2 is 7 upon 3. So 3 and then 2x plus 3 upon x minus 1 is equals to 2 goes on the other side, it is added up. 7 over 3 plus 2 is 13 upon 3. Then this 3 is being multiplied. Multiply कर दूं एक ही बात है. And then I cross multiply 3 3 the 9 2 are 18x plus 27 is 13x minus 13. 5x is minus 14. X is negative 14 over 5. Minus 27 and minus 13 will be minus 40, and then this is minus 8. Minus 8? हम दोबारा देखें. Okay, this is March 19. 1-2, question number 9. Express this in the form of this. We need to change it into the completed square form. Yeah. So yeah. Okay, this is how we convert the following into a completed square form. Then the question says the function f is defined by fx is 2x square plus 12x plus 11, and the domain is x is less than equal to 2. Find an expression for f inverse and state the domain of f inverse. I suggest that you make a sketch from this. Convert this into a sketch, and how will you form the sketch? Happy face? Happy face minus 3 minus 7. Minus 3 and minus 7 are the vertex or the coordinates of the turning point. Is this clear? But the domain has been provided x is less than or equal to -4. So for this particular domain, I just make a sketch. I am on the left side of the turning point, right? So if I plug in the value of -4, what is the value of the function? Plug in the value -4. minus 5. Now I know that for this domain, my range will be greater than or equal to minus 5 because the function is going up. Is this right? And now I need to find the inverse. Y is equals to 2x plus 3 whole square minus 7y plus 7 upon 2 is equals to x plus 3 whole square plus minus square root of y plus 7 upon 3 is equals to x plus 3. Now, how do we decide this? That whether we need a positive root or a negative root for the inverse function. Before even making the inverse, I already know that the range of my inverse will be less than or equal to negative 4. Once I know that my inverse will always be negative 4 or lesser, the root will be so the range of the inverse, which is the domain of the function, will help you decide whether to take the positive root or the negative root. Then comes the C part. The function g is defined by g of x is 2x minus 3 for x is less than equal to k. For the case where k is negative 1, that means you know it's a positive gradient straight line. The domain has been provided k is negative 1. Solve the equation f g x is equals to 193. So I already know fx. Let me write fx again. Completed square form of fx. Now, what will fgx be? Very good. We put the entire function of g in fx. 2x minus 3 plus 3 squared minus 7. And the entire thing is equal to 2x whole square minus 7 is equals to 193. Solve and tell me the value of x that you get. 7 goes, it adds over there. 200 divided by 2 is 100. 4x square is, or I can say that 100. If I take roots on both sides, 2x is positive 10 or 2x is negative 10. So what is the value of x? 5 or negative 5? Which one should I take? Which solution should we consider? Why? So, very good. In the composite FGX, the domain of G will be obeyed. So the domain of G for this particular part is defined that x has to be less than or equal to negative 1. So we'll take the value x is equals to negative 5. So you always get the same value or positive leading or negative. Now comes the last part of this one, which is part D. State the largest value of k for the composition fg to be defined. Now I know in order for fg to be defined, the range of g must lie within the domain of f. So if I don't know the value of k, but I know x is less than equal to k. So for this domain, what is my range? What is the range of g? I can say that my g of x will always be less than equals to 2k minus 3. If I plug in the value k, I get 2k minus 3. It's a positive gradient line. If I decrease the inputs, the outputs are decreased. Is this right? Now I know this is a value. I don't know what value it is, but this value must be lesser than or equal to negative 4. Find the value of k. Find the value of k. Less than or equal to negative half. So I'll say that the largest value of k is negative half. We have to write it separately that the largest value of k is negative half. Is this clear? Okay. Now this is a question, number 5 question. A function f is defined by fx is 2x minus 3 ka whole cube minus 8 for x is in between 2 and 4. Find an expression in terms of x for f dash x. What is f dash x? The derivative of x. Do that first. पहले वो काम करो. F derivative of x 2x minus 3 whole cube minus 8. Write it as fx. fx. What will be the derivative of 8? What about the power? And what is the entire thing? F dash x. No, the moment the step in which you differentiate, you write the entire thing as f dash x. So this is the derivative. Agreed? A function is increasing if its gradient is positive, or in other words, its derivative is positive. I already know that this is a square, and the square will be greater than or equal to 0 for all values of x. Right? Squares are never negative for real numbers. So I know that squares will be greater than or equal to 0 for all values of x. What will it be 0 for? ये 0 किस पे होगा? बस ये बात बताओ. When will you get the entire square as 0? Value निकाल कर बताओ क्या आएगी? 3 इधर ले जाओ, 1.5 आएगी, right? So for all values of x, this will be greater than or equal to 0. But for 1.5, this will be equal to 0. Does the domain include 1.5? The domain does not include 1.5. That means that it will be greater than 0 for the given domain. Is this clear? सिर्फ सर हमें पता है 1.5 पे 0 होगी, बाकी सब पे तो हमेशा पॉजिटिव ही रहेगी. तो स्क्वायर है वो, स्क्वायर जाने तो नेगेटिव. For the given domain, it will always be positive, so the function will always be increasing. So the derivative is what tells us whether the function is increasing or decreasing. जल्दी से ये वाला करो. Number 13, 1, 2, question number 9. Okay, so how do you find the derivative? First, simplify the entire function, bring 1 minus 3x up with the negative 1 power, and then we differentiate. This is our derivative. Again, in this case, we know that the denominator will always be greater than 0. Why? Because it will be 0 for, what value will it be 0 for? 1 upon 3. Is 1 upon 3 a part of the domain? So for all the given domain of all the values that are provided in the question, x is greater than or equal to 1, the denominator will always be positive. And if the denominator is positive and the numerator is 15, the final function or the final fraction will always be positive. So this function will always be an increasing function. Is this clear? इसको लिखो, ये notations लिखना सीखो. बोलो. 1 upon 3. You put this entire thing equal to 0. X goes on the other side. Okay, और करते हैं function का increasing और decreasing के थोड़ा clarity आ जाए. Do this one. Yes, class. So first we differentiate this. What is the derivative? Is this the derivative? Because that's a different part, and that x square is a different thing altogether. This is the derivative. Now for the given domain, what is the question provided you with? That this is the domain. X की वैल्यू में -1 से छोटी डालूंगा. अगेन सर आप -1 से छोटी वैल्यू डालें, कुछ भी डालें, ये डिनोमिनेटर आपका पॉजिटिव आ जाएगा. If the denominator is positive, ये पूरी this entire value will always be negative for the given domain. और इसके अंदर जब -1 से छोटी वैल्यू डालूंगा in place of this x, so again this entire thing will also become negative. So my derivative will always be negative. Two negatives adding up will always give me negative. So negatives multiply नहीं हो रही है. Understand this. So two negatives adding up still negative, and when the function is always negative, or sorry, when the derivative is always negative, we can say that the function is a decreasing function. Is this clear? You will have to write all these notations to make sure that the examiner understands this entire thing. ये वरना ये नहीं कि मैंने लिख दिया तो सारा आंसर हो गया. No. Yes, write it down. 2x है ना. मैंने कहा 2x तो वैसे तो नहीं, I cannot comment, but 2x will be negative for the given domain. Hence, two negatives adding up will always give me a negative. Done? Now attempt this one. March 21, 1, 2. Okay, so first we completed this function, completing the square. X plus 1 whole square plus 1. Now we know it's a happy phase. And what are the coordinates of the turning point? -1, comma 2. And the domain is x must be less than or equal to -1. That means we are taking from the turning point and leftwards. But the range is, because of a curve is going up, so the range is fx is greater than or equal to 2. Part B, obtain expression for f inverse of x. Class. First we attempt to make x the subject of the formula. How do we decide that whether to use the positive root or the negative root? The range of the inverse or the domain of the function guides us. The domain of the function is stated that x is less than or equal to -1. So I can say that f inverse of x will always be less than or equal to -1. Now if I know कि -1 से छोटा होना, it has to be lesser than -1. So I'll use the negative sign with the root. Is this clear? That's it. We also